This is just a really quick video showing you a little bit about how to use the plugin Dendro, which is going to um, enable you to turn things like points and curves in Rhino into like completely joined, uniform, watertight meshes. It's really good for creating models for 3D printing if that's something that you wanted to do, or just generally making kind of organic or amorphous forms. So over here in my Rhino window, I'm going to draw a couple of curves to create some kind of mesh around. I'll just draw some wavy curve forms here. And I'm just drawing them in front view so they're kind of vertical. And we can go back and always change these later. Okay, let's start with that. So over here in perspective, I'll maximize. You can see they're kind of in 3D there. So we can also move them other dimensions and have them be a little more three-dimensional. Using those control points. And it's important that they're a little bit close, but they don't have to be like perfectly touching down at the bottom and things like that if we don't have for Dendro to work. Get those to touch in the center. All right, so what I'm going to do is take these curves. Doesn't matter how long they are. Again, doesn't matter if they're touching. You want them to be close, where you want them to join, obviously, but doesn't matter if they're perfect. And then I'm going to put them into Grasshopper. So over here in Grasshopper, just get a generic curve component. Click that curve component there. Right-click and go to Set Multiple. Then what I want to do, so Dendro, again, can take either a curve or a series of points. So over here on the Dendro tab, this is the name of the plugin. If you go to foodforrhino.com, you can download and install it. But over here where it says convert, we have a couple of different options. So I'll show you the curve version first. So that first option is going to be curve to volume. So if I just go ahead and plug these curves into this component, and then I have to set a radius for like how large around each of those curves, kind of like the pipe tool, how large I want those pipes to go. And then finally, I also need to set some settings. Also under convert, go to create settings. And the main setting that Dendro wants us to input is the size of the voxels. In other words, the size of like the subdivisions on the mesh. And there needs to be a certain minimum size. It has to be a certain degree smaller than the actual radius in order for Dendro to work. So I'll create another number slider. Here we go. And then it needs to be like, here we go. It needs to be, I don't remember how much, but a little bit smaller than this number essentially for Dendro to work. As I drag this down, you'll see it'll disappear again. Very small. But this actually does represent kind of the resolution of the mesh that Dendro is creating. So you can see right there, it's automatically creating this kind of like single mesh. Now, if I were to go ahead and bake this, I can right click and just go to bake. So I have a mesh already. Again, that should be a watertight, I'll put in shaded, watertight joined mesh. For whatever reason, it usually seems to put the meshes inside out. So meshes like surfaces have a kind of inside and outside or a direction that they face. So if I were to select this and just type in flip, now you can see it's not see-through anymore. But so if you look at the kind of lines of how it's subdivided, that's what this number is. So the smaller that number is, the smaller those little kind of subdivisions on the face will be. And of course, the bigger the slower your Grasshopper will go, and the bigger your Rhino file will be, and all that fun stuff. So, but what if we wanted to make a version of this where it gets like larger from bottom to top? So as it goes up, it kind of it's thicker. So instead of using curves, we can also use points using the points to volume tool in Dendro. So I'm going to go ahead and delete this one first of all. And what I need to do in order to get this to work is divide the curves into points. I can just use a divide curve to do that. Obviously my curve goes into that. Now you can see because they're all different lengths, they're kind of being subdivided. The points are at different spacings. What I want is to have the number of subdivisions of the curve relate to the length of the curve. So I can go just double click, get a length component. That just tells us the length of the curve as a number. Then I'll get a division component, type in your slash in the search bar, and I'll divide that by a number slider. 1, plug that into the n. And so basically that number slider, as I make it smaller, you'll see that I'll get more points. So this kind of represents like how far apart the points are on the curve. So the smaller that number, the more points I'll have. So we'll start with something like that. So I'll go ahead and plug these in. Now, one thing I do want to do, because I want them all to be joined together, it's not like I want a separate mesh for each curve or each set of points. I'm going to make sure that this line, this dash line here, means that I have a grafted list. I want that to not be grafted. I'll just right click on the P and go to flatten. Now I have a solid line. And I'll just use the radius and the settings that I used before. And now you can see it's doing pretty much the same thing it was before. It's joining them into one. But if I wanted to give them, again, make it taper from top to bottom, I could give it a range of radii or radiuses to kind of make it taper along the length of the curve. So in order to do that, what I want to do is deconstruct point. Deconstruct, not construct. So I want the one that looks like this, that says deconstruct, that goes like X, Y, Z. And if you read the little description, it says deconstruct into its component parts. That's what I want. So this is going to deconstruct each of the points on the curve into X, Y, and Z, X, Y, and Z components. So it'll tell me basically how high off of the 0, 0 of my file each point is. And I can use that to control the radii. In other words, however high my point is can relate to how large the kind of pipe that's around that curve is going. So what I'll do is I'll get a remap, use these, I'll remap the Z values to new numbers to control those radii. So those are going to go into the Z is going to go into my values. I also want to get a bounds component. This will give me the kind of minimum and maximum domain of my Z values or my height values. And then I'll get a construct domain, just the one that's a 0, 1, not the construct domain squared guy. And that's going to be, so like I'll take whatever these Z values are from start to finish. So yeah, they go from 0 to about 0 to about 3. And I'll remap them to numbers that are closer to the radii values that I want to use. So let me copy paste this slider here. And we know the minimum has to be a little bit larger than that minimum voxel size. And then I'll go ahead and plug that into my radii. So. All right, so, and you'll see that like the lower number is going to change the size of the points that are lower down in the Z, dimension of my curve. And of course, when I go below a certain size of this number, they'll actually stop making a mesh around it, around those points. And then as I move this slider up, you can see that's controlling what's happening on the larger end. And so I can get it to kind of taper in that way. And yeah, so the other thing, just real quick, display. I'm going to turn on preview mesh edges. Here we go. And then I think, so again, I need to flip the mesh. Flip the mesh. What do I want? No, sorry. This may or may not be a plugin. I'll just type in flip. There you go. Mesh flip is what I want. So yeah, again, it's kind of turned inside out, but that'll give me a preview of how large those kind of subdivisions are. And now if I change this and make it smaller again, that's going to give me kind of a higher resolution. But you'll notice that if you make it too small, what starts to happen is that the individual is get these little humps, which basically are like, it's making a sphere in a way around each point that I've divided the curve into. And so you'll see some of these transitions will become more pronounced the lower the resolution of my mesh. So just so you're aware, that's a number that you kind of want to balance so that it appears to be kind of a smoother transition between multiple curves and um, also between the points along the mesh. Again, you can also change that value still by moving this slider around. So again, higher numbers, you'll see again, that'll kind of express individual points as like spheres more. It'll give you a more segmented looking thing. And then lower numbers, meaning more points, will kind of smooth that out a little bit more. And then when you're done, so you can also just bake that guy. Oops. There you go. And you'll see that it's one, continuous solid mesh. So really super useful for those organic forms. All right.